Hello all. In the previous part, we have learned a technique to graph a linear equation. We have seen that the graph of a linear equation is clearly a straight line, and to uniquely determine a straight line, we need just 2 points. And for this case, we consider those 2 points to be the x-intercept and y-intercept. Right. So if we get a linear equation to graph, we first find the x-intercept and then the y-intercept. We mark them on the coordinate system, the Cartesian coordinate system, and we connect them with a straight line. That's the strategy. So let's hit an example so that the things will be a little more clear. So graph the equation y equal to minus 1 by 2x plus 4. Right. So what was the strategy? We just need to find the two intercepts and join them with a straight line. So which are the two intercepts here? So how do we find the x-intercept? What do we mean by x-intercept? X-intercept is the point where the graph crosses x-axis. So obviously it is a point on the x-axis, and we know that all the points on x-axis will have y value 0. Right. The points on x-axis will have its y coordinate to be 0. So we use y equal to 0 here, which will give us the information that 0 equal to 1 by 2 x plus 4, which means 1 by 2 x equal to 4 implies x equal to 8. Right. So when y equal to 0 and x equal to 8, so the x-intercept has to be 8, 0. Similarly, can we find y-intercept here? So what's happening on the y-intercept? What's so special about y-intercept? Y-intercept is the point at which the graph crosses y-axis. Obviously, for this reason, it has to be on the y-axis. So the points on the y-axis will have its x-coordinate 0. So we choose x equal to 0 here. So we'll have y equal to 1 by 2 times 0 is 0, so 4. Right. So the point is 0, 4. Right. So now let's start graphing. Now we got 2 points, which is all we need to draw a straight line. So consider this to be our coordinate axis. So choose this to be x-axis, this to be the y-axis, and the negative directions on the other hand. Now let me graduate this. Oh, we need more than this. That's fine. Let's mark this to 2, 4, 6, and 8. 2, 4, 6, and 8. Right. So now let's mark the 2 points, the two intercepts. The x-intercept is 8, 0, which is on this point, and the y-intercept is at 0, 4, which is at this point. And now we are supposed to connect these 2 points by means of a straight line. Right. So this straight line gives the graph of the function, you can use the word function, the equation y equal to 1 by 2 x plus 4. Right. So what we have done, we found the two intercepts, mark them on the coordinate system, join them using a straight line. Right. Perfect. So this is how we graph a linear equation. You might have noticed that the function or the equation to be graphed is given in the slope-intercept formula. Is it always necessary that the equation to be graphed will be given in the slope-intercept form? No, it is not. It may not be in the same form. It can be of any other form, but we can easily rearrange the terms so that it will be in this form. Right. So for example, consider an equation 3x plus 5y equal to 35. Right. So can you convert this to slope intercept form or y equal to mx plus c form? where m and c, or mx plus b, where m and b are constants. So let's keep y here, y term here, 5y equal to minus 3x plus 35. So y equal to minus 3 by 5, x plus 35 by 5 is 7. Right. So this is how we obtain the corresponding slope intercept form of any equation. Right. So this can drastically make our work easier. So I strongly recommend you to change any equation to the slope intercept form before proceeding to graph. Right. Now we know how to practically graph a linear equation. Now let's go a little more closer to the graph. Nothing but the straight line. So as an interesting property of a straight line, let's think about the slope of a straight line. So what do we mean by the slope of a straight line? As we have explained later, slope actually measures how inclined is it, or how steeper is it. Right. So consider two straight lines for a sake of comparison. This one, and say this one. So from our layman's point of view, we may obviously claim that the slope of this is quite less than this, and that of this is again less than this. So among these three straight lines, we identify this straight line, say C. If I name this as A, B and C, we may identify the straight line C as the line with the maximum slope or the highest slope, and B comes in between A and C, and A with the least or the smallest slope. Right. So this is what we actually mean by slope, and we have a little mathematical explanation for this idea of slope. Before proceeding to the formal definition or the formula for slope, what is the slope of a horizontal line? So consider the coordinate axis x, y axis. If I draw a line which is parallel to x axis, or in other words, it's a horizontal line, the slope of a horizontal line is defined as 0. Right. The slope of a horizontal line is defined as 0. And what about the slope of a line parallel to y-axis? A vertical line. So far, for a vertical line, the slope is not defined. So you can just write slope is not defined. Right. So for a horizontal line, the slope is always 0, and for a vertical line, the slope is not defined. Right. So now let's think about a mathematical method to possibly calculate the slope of a straight line. Suppose we have a straight line. We have seen that a straight line can be uniquely identified with 2 points. Right. So suppose we have a straight line passing through 2 points, say x1, y1 and x2, y2. Right. Then the slope of this straight line passing through x1, y1 and x2, y2 can be calculated as m. We use the letter m to denote slope. M as y2 minus y1 by x2 minus x1, or equivalently m equal to y1 minus y2 by m1 minus m2. Both of these expressions are identical. Will be a negative introduced both in both numerator and denominator over this side, which will be obviously cancelled. So you can use either of these expressions to algebraically or practically evaluate the slope of a straight line given 2 points through which the straight line passes. Right. Now we know how to practically calculate the slope of a straight line given the 2 points through which the line passes. Right. Now we try to introduce a new method to write the equation of a straight line given the slope and a single point through which the line passes. Right. So what are the information we have about a straight line? The slope of that line and a single point through which the line passes. Right. So the equation for the line through passing through x1, y1 with a slope of m is given as y minus y1 equal to m into x minus x1. Right. So this form of equation for a straight line is called the point slope form. Right. You have seen this before. We have discussed about the intercept slope form or the slope intercept form. The slope intercept form was actually a special case of this point slope form, where this particular point happens to be the y-intercept. Which means if you choose this point x1, y1 to be the y-intercept, we'll have the slope intercept form from point slope form. Right. So to uniquely determine a straight line, we need the slope and a single point through which the line passes. Let's try an example. So what could be the equation of a straight line passing through 3, 10 with a slope of -4. See, the slope need not be always positive. The slope can be negative as well. For example, a straight line of this orientation will be having a positive slope, and a straight line of the other orientation will be having a negative slope. There is a reason for this, since slope is actually defined as the tangent of the angle which the angle which the line makes with positive x-axis, and the tangent value of angle for such a line happens to be negative. Right. So we'll explain these things if it comes under our syllabus later. For now, just remind that slope need not be always positive. Slope can be 0 as we have seen for horizontal lines, and slope can be negative. Right. In fact, the sign of slope determines the orientation. So if the line is oriented with in this way, the slope will be positive, and if it is in this way, the slope will be negative. Right. So in our particular case, we have a straight line passing through 3, 10 and has a slope -4. So what could be the equation of this straight line? So the general form was y minus y1 equal to m into x minus x1. Right. So what is x1, y1 here? 3, 10, and slope m is equal to -4. So plug in all those values into this general form, which will give us y minus 10 gives -4 into x minus 3. Simplifying this, we'll get y minus 10 equal to -4x plus 12 implies y equal to -4x plus 22. Right. So this is the equation for the line with slope -4 and passing through 3, 10. Right. So equation is y equal to -4x plus 22. Perfect. So that was about graph and slope. Do you remember what we have told about solutions of a system? Right, they were the numbers which can be substituted for the variable so that the equation will be an identity. Right. What we have to solve two equations simultaneously. Right. So we have two equations in same variables. Say some ax plus by equal to c and dx plus ey equal to f. So we have two equations here, both are in x and y. Can we solve them simultaneously? Right, which means can we find a single solution which will work for both of these equations? That's the question. And interestingly, the answer is yes. Sometimes we can find a common solution and sometimes we cannot. Right. So there are two methods to find a common solution for two equations simultaneously. One is algebraic method. So let's explain the methods first and later go to an example. So algebraic method consists of three steps. So one is convert all the given equations to slope-intercept form. Convert all the equations given to slope-intercept form. And the second step is, see, when we convert the equations to slope-intercept form, it will be of the form y equal to some mx plus b, and the other equation will be something like y equal to some nx plus e or something. Whatever the left hand side will be y, which is the same, so we can equate the right hand side, and that's the second step. Equate equations for y and solve for x. The words will be a little more clear when we move to an example. And the third step is, once we get a value, once we solve for x, we will get a value for x and use that value in any of these equations to solve or to find a value for y. So use value of x to solve for y. Right. So this is the algebraic method to solve two equations simultaneously. So what is the other method? The other method is using graphs or the graphical method. Graphical method. So we have two equations, two linear equations, and we know how to graph those two linear equations. Right. So to find the common solution to two linear equations graphically, there are two steps. Graph both equations. Right. So you will get two straight lines. So graph both equations on the same plane. Don't graph it on different planes. So graph both equations on same plane. And now you have two straight lines, and look for the point of intersection, if any. Look for the point of intersection, if any. It is not necessary that two straight lines always intersect each other, but sometimes they may intersect, and that particular point of intersection will give us the solution. See, that particular point of intersection, using the Cartesian coordinate system, we can identify that point with a pair x, y, say x0, y0, and these two values will give the solution for x and y, which will solve the two equations simultaneously. So now let's try an example. So consider these two equations, 2x plus y equal to 10 and 3x minus 2y equal to 8. So we need to solve these two equations simultaneously. So let's follow the algebraic method first. What was the first step of algebraic method? To convert both these equations to slope-intercept form. So which is y equals minus 2x plus 10, and from here we will get 2y equal to 3x minus 8 and y equal to 3 by 2 x minus 4. Right, 3 by 2 x minus 4. Let's write it here, 3 by 2 x minus 4. Now second step, solve, equate and solve for x. So we have y and y on the left hand side, so we can equate the right hand side. Minus 2x plus 10 equal to 3 by 2x minus 4. So bringing all these x terms to one side, minus 2x minus 3 by 2x equal to minus 14. So what is minus 2x minus 3 by 2x? Minus 7 by 2x equal to minus 14. So 7 by 2x is equal to 14. So 7x equal to 28, which means x equal to 4. Right. So we equated the right hand side and found the value for x as 4. Now we may use, as the third step, we may use this value of x to find the value for y in any of these equations. So let's choose the first equation. Right. So 2 into value for x is 4 plus y equal to 10, which implies 8 plus y equal to 10. So which gives y equal to 10 minus 8 is 2. Right. So we got the point x equal to 4 and y equal to 2 as the solution. Now you may verify whether this particular solution works for both. So what for the first equation? If we choose x equal to 4 and y equal to 2, we'll get 2 into 4, 8 plus 2 equal to 10. Yeah, perfect. For the second equation, 3 into 4, 12 minus 2 into 2, 4. So 12 minus 4, 8. Right. So this works for both equations. So that's how we solve two equations simultaneously in algebraic form. Now how to solve this graphically? We'll draw the graph. For this, we'll obviously, as we know the solution, we'll be having graphs of the form this. You have to try this back home. So we'll get such graphs which will intersect at 4, 2, and we identify that point to be the solution, the common solution for both equations. Right. So that's all about simultaneous equations. Now again a redundant concept for you, the quadratic equations. So what is a quadratic equation? An equation of the form ax square plus bx plus c equal to 0 is called a quadratic equation where a, b, c are constants, and a not equal to 0. Why do we need to fix a constraint that a not equal to 0? If a equal to 0, the term of x square will be 0 and what will be left? It's again a linear equation. Right. So a quadratic equation needs to be of power 2. So to retain this equation with power 2, a has to be non-zero. So an equation of the form ax square plus bx plus c equal to 0 with a, b and c be constants and a non-zero is called a quadratic equation. And we know better ways to solve quadratic equations. Quadratic equations can be solved by either by factorizing or directly using the quadratic formula, which is nothing but x is equal to minus b plus or minus root of b square minus 4ac by 2a. Right. A, B, C comes from the equation. Substituting or plugging in the values for A, B and C, we'll get the solutions. Right. Unlike the linear equation, a quadratic equation may have a unique solution or two solutions, or it may not have a solution. Like we have seen such cases in linear equation as well. So remember, it is not necessary that a quadratic equation always have a unique solution. It can, in most cases, it can have two different solutions.